皆様大変長らくお待たせいたしました。ただいまより Intro to Virtualization 101と題しましてセッションを行ってまいります。こちらは同時通訳講演となっております。ご聴講の際は皆様のお席にご用意しております同時通訳レシーバー、こちらをご利用ください。日本語はチャンネル1番となっております。それでは Nvidia ジェレミー・メインより講演を行います。よろしくお願いいたします。
こんにちは、皆さん。Nvidia のジェレミー・メインと申します。最近通勤の時にスピードラーニングですごい勉強を頑張って今日はちょっと英語はチャレンジしましょう。So today I'm going to talk about the basics of virtualization. This is not intended to be a deep dive into virtualization technologies, but to be an introduction to understand why Nvidia cares about virtualization and GPU virtualization in general. So first, we need to talk about why we need to virtualize and why virtualization has been accepted and deployed by businesses worldwide. Then I'd like to talk to you about why Nvidia really cares about virtualization. And lastly, I'd like to talk about how you can use our grid trial to understand how simple it is to deploy virtualization with GPU virtualization into your own workspace. So, what drove virtualization? Many years ago, each server had an OS running on a dedicated server, and a lot of people had looked at these servers and found that each server and each server OS was not having much utilization. And of course, we all understand that underutilized hardware means we paid too much for the servers. We pay too much for the IT and the power. So with virtualization, we've taken all of these server OSs and migrated them to a single server or multiple servers that can host several virtual machines running server OSs on a single platform. But virtualization is not just for servers and server OSs anymore. Virtualization is also about providing desktops and applications to users, and hopefully with GPUs enabled. So what are the advantages of virtualization? Simply put, there's many different advantages for virtualization, but I'd like to touch on three primary points. One would be partitioning and portability, and finally security. For partitioning, that's the ability to run multiple operating systems on one physical machine. That machine hosting a hypervisor that has several operating systems running at the same time. When you're running on one server, you have the ability to share all the resources, the memory, the CPU, fast storage, between all the virtual machines. Now, for portability, each virtual machine that is running on a hypervisor is stored as a file. Because it's image-based, you have the ability to export, copy, and also easily back up virtual machines and their settings in simple operations. Now, security is interesting because before, when we had desktop-based systems, we had to think about the OS crashing the operating system, or the applications crashing the operating system, Whereas in a virtual environment, there's less likelihood that the virtual machine can crash the entire computer because the operating system is isolated or virtualized from the actual physical hardware. So we talked just briefly about server virtualization, but what about desktop virtualization? What are the merits? Well, long time ago, not too long ago, we used to think of desktops and workers as having one desktop, one worker, and if you're lucky, that one worker had multiple machines. And from a resource management perspective, all of those desktops, all of those operating systems, all of those applications are very difficult to manage from an IT perspective. Also, every 3 to 5 years, those desktop PCs need to be replaced. And depending on the use case, sometimes those desktop machines need to be replaced at a much frequent cycle. So high-end users often demanded having workspaces that were much higher performing than your typical knowledge worker that's doing simple workflows. So having customizability for each desktop is a very important point that people want to remain with a non-virtualized desktop. So regarding application virtualization, actually application virtualization came before proper desktop virtualization ever happened. Now, so application virtualization allows the distribution of multiple copies of an application from a single physical server. These applications can be streamed to different devices, whether it be a netbook or a notebook. It can also be streamed to a workstation. And from an IT perspective, this is a very easy way to deploy applications to users. Some typical solutions that have been around for quite some time, for example, Citrix was called MetaFrame, then it was Presentation Server, and now it's known as XenApp. And I'm sure anytime now they'll probably change the name again. Also, VMware also has ThinApp, and also Microsoft's AppV are all examples of application virtualization. So how were servers migrated to virtual machines, virtual servers on a hypervisor? Well, first you take the same physical server, and then you take that server and you put that in a different role. On top of that, you put your hypervisor, and then you migrate your server OSs onto that hypervisor, and you can deploy multiple virtual servers on a single commodity server that previously was being used as a single server OS on that piece of hardware. Now, this migration gives you a lot of advantages because you're having much higher utilization of that server, and you can invest resources into higher spec CPUs, memory, and storage subsystems for each server. So how about going from desktops? You have a physical workstation. If you want to virtualize that workstation in a hypervisor, you use the same physical server hardware that we utilized before, and you use your hypervisor and migrate that physical workstation to that server. And you can add multiple virtual machines running virtual workstation operating systems on that same server. And the benefits are also the same for virtual desktops that the virtual servers also enjoy. which include higher resource utilization, better flexibility, being able to access that virtual workspace from virtually any location, and to have higher standard performance in that virtual machine. So Nvidia, we make GPUs, right? So why do we care about virtualization? It comes down to this. CPUs are good for serial tasks. And in a virtualized environment, CPUs have a lot of things to do. CPUs have to do regular processing for applications. They have to manage network resources, storage resources, and finally, if they have to emulate a GPU, then that's going to lower the user performance even more. Now, GPUs are designed for highly parallel operations. They're very good at rendering, and they're very good at parallel processing. And adding a GPU to the server environment allows the CPU to concentrate on the workloads that it's most efficient at and utilize the GPU to do its most efficient work. So if you look at how graphics have been rendered in virtual environments up until maybe a year ago, users were greeted with a 1990s experience of graphics experience. The shading, it's okay, but when you start interacting with the model and you start trying to do operations with it, you find that the interactivity and the frame rates during rotations or sketching is not very good. When you have a GPU integrated into the server and you can use the latest GPU effects that are available to the application, and depending on what solution you use, that can be the latest OpenGL drivers or the latest DirectX drivers. So you can have the standard workstation experience in a virtual machine if you have a GPU and Nvidia's technology integrated as well. So part of the journey towards virtualization, this is talking primarily from Nvidia's standpoint, but if you think about your users that you want to virtualize, you need to understand how to segment your user group populations. And here we have, I'm sure many of you have probably seen this before, but we have three different large segments, and at the very top is the designer. Now, the designers are the highest paid, most productive workers in organizations that typically have high-powered, high-resource, very expensive workstations. And their size in the overall market is very small, but they are very key to enabling the company to design the products that sell. Now, underneath this designer is power users. They are the people that utilize 3D graphics. They utilize PLM applications. They also might watch training videos or other things that can be accelerated by a GPU. Now, at the bottom is a knowledge worker. And knowledge workers can have regular applications like Microsoft Office. They could have web-based applications. It's a very large market that even for basic applications can be accelerated using a GPU in a VDI environment. So it's really important to understand what users in your organization, how you can segment them, perhaps in a manufacturing environment or a manufacturing business. you might not have a designer. You might only be consuming data that's maybe at a power user level. So you need to analyze what applications you're using and leveraging and decide if a GPU, how much value that's going to bring to your VDI deployment. So here, the importance of having a GPU is broken down. And for a designer, would it be nice to have a GPU? No, it's critical for a designer to have a GPU because without a GPU, they cannot create the content, the automobiles, the dishwashers, the airplanes, the whole realm of products that we create using three-dimensional graphics. Now for power users, they of course use office productivity applications, but they also interact with the data that the designers create through PLM applications or viewing applications. And finally, the knowledge workers might only use as well the office productivity applications, but also there's a high tendency to have web-based applications. And depending on the type of web application, if it utilizes Flash or HTML5, that too can be accelerated by a GPU. So what Nvidia is doing is delivering the missing ingredient for VDI. Our grid products, one of the key features of our grid products is that it utilizes the same Quadro drivers that are accepted in the industry as a standard by most ISV applications. Many years of testing, thorough testing, and compatibility testing by Nvidia, as well as ISVs, to certify that those applications will run correctly and will give an excellent visual experience. Because ultimately, if you give a user a subpar user experience, they're not going to be happy with their VDI deployment. So how difficult is it to move to a VDI deployment? Well, simply, I'm not sure how to interact with this, but on your left side, you have your guest OS, and inside there is the Nvidia Driver. Now, that Nvidia Driver has been para-virtualized to talk to the GPU in the hypervisor or via PCI pass-through. So you can have any number of GPU cards in a server. There are limitations for each server platform, but once you enable the GPU in the virtual machine, that can then be delivered to the virtual desktops, and clients can connect to that virtual desktop and utilize all those applications from any different location. So talking simply is easy, but if you actually look at a standard deployment, what sort of different parts are required to manage a VDI deployment? So you have storage, networking, VPN. On top of, there's 5 main layers. There's the user layer, the access layer, control layer, resource layer, and finally the hardware layer. This is pretty complicated stuff. So it's important to understand that moving to VDI is not as simple as buying a machine and sticking a GPU in it and bang, you're ready to go. So here's the top 10 lists of how to fail at VDI. Okay. Everyone having fun? Okay, no one is. Good. All right, okay, thank you. So number 1, believe desktop and server virtualization are the same. That's a common mistake. Desktops and servers have different strengths and weaknesses. The weakness of desktop virtualization is you have to have high interactivity with low latency, whereas a server has to have high processing performance and doesn't typically have any user interaction in a console setting. Second one is doing too much. When you initially try to evaluate a VDI deployment, you try to build something that resembles your final production deployment. And if you don't have experience setting this up, you're almost destined to fail by making it too complicated. And number 3 is not knowing why you're virtualizing. So if you don't have a business reason for virtualizing, and you can't sell that to management and you can't sell it to your users, then maybe IT is the only people that are driving virtualization. You have to make sure you have the buy-in from management. You have to have the buy-in from users, and to be able to explain that the merits of moving to VDI. So often we think of a solution will solve a problem, but sometimes we only think of this problem without actually thinking through to what it's supposed to solve. So for number 4 is forgetting the user environment. If you forget that the end user will be using a desktop-based VDI and what changes that will affect for each user, then that's something that your users might not be happy with. If one day you have this really big workstation on your desk and you have 32 gigs of memory and maybe a 16-core processor, then the following day you have a tiny thin client with a 15-inch, I know they don't make 15-inch monitors anymore, but let's say a 17-inch monitor. And now you have a much slower desktop environment without considering what the user experience was before. So it's key to understand what the users are used to and give them something better. Okay, so number 5 is hanging on to bad habits. Bad habits can be allowing your users to install any application on their personal machine. When you move to VDI, usually you want to lock down the desktops, maybe build a master image of the operating system, and then publish applications to users. So eliminating the extreme customization that users enjoy now, giving them some flexibility, but don't let them control the entire environment. And for number 6, sorry I'm reading this off like a top 10 list, but it's easier to go that way. Misjudging how your VDI will scale. Sometimes in the initial deployment phase, how to scale out throughout the organization isn't thought out. And so first you buy a server architecture that maybe can support 16 users. And as you increase density, maybe you try to cram in 32 users into that server, and then everyone starts having poor performance on their desktop. Or perhaps you did local storage on each server as opposed to using a SAN. These are all things that can affect how you can scale that deployment. So it's important to have companies or integrators that are experienced with large deployments, or that can explain the benefits of starting small and expanding to a larger deployment. Also, misunderstanding Microsoft's licensing. Now, this is something that maybe should be at the top, but licensing virtual machines needs to be discussed seriously with your IT department and with Microsoft, because each virtual machine needs to have, if you're running Windows, needs to have an actual license. So for large organizations, they might already have a volume license agreement with Microsoft. So that's something that you can't take one virtual machine and license that and then share that license with everyone. That would be not a good thing for Microsoft. So thanks. Also, sometimes when virtualization first came out, it was pushed as a way to save money. And it's easy to confuse that it's going to save you money. If you look in the long term, maybe it will save you money. But VDI traditionally costs maybe a little bit less than certain workstations, but it's definitely not a big money saver. So these are things that you need to consider. What else? I'm going to skip not working together because that's pretty clear. And then also underestimating the virtual desktop requirements. Now, who's actually done a VDI deployment or has a VDI deployment in their organization? Just raise your hand. Okay, no one. Okay, thank you. So if your virtual desktop requirements aren't clear, what workstation or what machine have your users used up to now? How many cores did it have, etc.? These are things that are critical to understand before moving into VDI. I'm running out of time, sorry. So the best way to approach this is to first, with Grid, look at our side-by-side videos on the internet and try out our test drive to understand the GPU and how that relates to virtual machines. We have case studies and white papers there for you. It's just a brief example of how GPUs and CPUs, is that playing? Did I stop that? I can't tell if it's playing or not. I'll pretend it did. Today at the session, we announced that in Japan we now have the test drive available, and I welcome everyone to try to see if a virtual machine with an Nvidia GPU integrated into it is something that your organization would be interested in deploying. Now, this test drive technology is not something we're selling. It's just an easy way for customers to evaluate it and hopefully get buy-in from their organization. Am I out of time?まだ時間ありますか? No? Okay. すいません、時間がもう終わって、ここでもう終わりましょう。なんか質問がございませんか？英語でも大丈夫。はい、どうぞ。Is there plans for CUDA? Okay. それ通訳してる？その質問。
Can you repeat the question
I can
again,
repeat. So,
please?
like if you have some hardcore news for hardcore users,
Yes.
Virtualization of CUDA.
Virtualization of CUDA is not something that's ready to be released in the market yet, but if you use the Grid K2 or K1 in a virtual machine via pass-through, then CUDA is available. vGPU, virtualized CUDA support, is not something currently that's being released. That's something you're going to have to wait a little bit for.
Okay,
But
thank you.
until that time, it's perfectly okay to use the K2 or K1 in pass-through.
Okay, thank you very much.
はい、よろしいでしょうか。 では以上をもちまして本セッションを終了とさせていただきます。